This will probably be the last day we spend on this. And then we'll move on to like doing other things with monomials and polynomials and all that stuff. Because today's like really our last day on unit 5 in algebra. We're retaking unit 5 today, and then starting Monday, we're moving on. So today's last day for exponent rules. We will, after we fill out this graphic organizer, we will do a maze, like a exponent rules maze, and that will count like as an assessment. Okay, so you'll want to make sure that this note sheet is filled out accurately, but make sure that if you made a mistake that you correct it and all the stuff. So it can help you with your maze. So first rule is adding and subtracting monomials. It's already filled in for you. The rule is combine like terms. Okay, so like 2x plus 3x, you get 5x, so like that type of thing. In those situations, you don't change the common variables in exponent. You're really just combining the coefficients, the numbers in front. So, and I really, on the ones that I checked, I don't know if we just didn't like see that we're supposed to do these, but I didn't see these filled out. Okay, so you're supposed to do that too. Anyway, so looking at the first example right here, are these like terms? Yeah. How do you know that they're like terms? They're both x squared y. They have the same exact variables to the same exact exponent. If one of them was different, even by a little bit, like say one of them was this instead, then it's not a like term. It has to be exactly the same, that part at least. When it's exactly the same, you combine the coefficients, the numbers in front. Combine means add, but depending on the sign that's there, it might seem like you're subtracting, same difference, because you can't add a negative number. So what's 9 minus 10? Negative 1. Same way if you thought 9 plus negative 10, you still get negative 1. Okay. And then rule is do not change the common variables in exponent. So it's still x squared y. Questions on that one? Do I need to write this 1? I don't need to. I could just leave the negative, but just I don't care if you write it. Okay. Down here, we're subtracting 6w from 8w. So is it this that I am doing, or this, which comes first when it says we're subtracting 6w from 8w? Okay, I heard both answers. Some other people chime in. So when you're subtracting from something else, from is like a switch word, is what we call it. So if it's subtracting 6w from 8w, you're gonna like switch the order. So really it should be the 8w minus the 6w. And then are these like terms? Yeah, they're both w to the first power. So then what's my answer going to be? 2w. All right. So questions on the first set. Okay. So then product rule. So the name of the rule, like product, is talking about what's going on between the bases, because product you associate with multiplying. So we're multiplying the bases. But what we do with the exponents is always different for the rules, for the exponent rules. So if I multiply the bases, what do I do with the exponents? You add them. Okay, so there you go. Now do the examples as well. H squared times h to the 6 gives me h to the 8, because according to the rule, we add them. Down here, they do not have to be like terms in order to multiply them. So, just follow the rules. Coefficients are normal though. Okay, so like -2 times 7 is good. So those you don't add, you multiply those normal. But the variables with the exponent you add. So like what will be on the A now? Good, 2 plus 3 is 5. And what will be on the B? Good. Because if it's not written, it's assumed to be 1. So 1 plus 1 is 2. All right, make sure we're copying down as we go. It's okay if you made a mistake. You'll need this for your name. And if you have questions, feel free to ask. All right, next one is power rule. So power is what's going on with the base, or like the name of the rule is what's going on with the base. We have a power raised to a power. That's why we call it the power rule. But what do we do with the exponents? Multiply them. So x to the a raised to the b is now x to the a times b. So in this one, x to the 2 raised to the 3 is going to be x to the 6. 2 times 3 is 6. Coefficients you would treat like normal. So like here I have this whole chunk all raised to the power of 2. Make sure you also do the coefficient to the power of 2. What's -2 squared? It should never be negative if you're squaring. Should be positive. And if your calculator told you otherwise, that's why you need to put parentheses before you take it to the power. That's like one of those positive things. All right, but then with the variable, you multiply the exponents. What's 5 times 2? So I have 4m to the 10 times m cubed, which we can still simplify even further. What do I get after that? So is this chunk still the power rule? No, now it's back to the product rule, which means you add the exponents. So 10 plus 3 is good. So now I have like some mixed stuff going on there. So yeah. Questions on that? So this is our final answer, but you can see we apply the power rule on this one. Yeah. Yeah, you have to, anything that's in the parentheses raised to a power has to be raised to that power, including the number that might be. So -2 squared is probably 4. Yes. All right, moving now. So quotient rule. Quotient you associate with division. So that's why between the bases, they are dividing. Why they call it that. But what do we do with the exponent? A minus B. Good. Subtract it. But of course, any coefficients you might have, you treat normally. 27 divided by 42 does not work out evenly, does it? No, but you can simplify the fraction. If you don't know how to simplify fractions, you could type it in Desmos and see what the simplified version would be. So what is this as a simplified fraction? Are you sure it's an 9/3? Okay, well, let me put it in. I gotta see this next one. Okay, so this is good for you guys to see that still struggle with the fractions. So we're simplifying 27 over 42, right? Gives me a decimal, but if you press this button, you get the simplified fraction. So maybe so 9 over 14. All right, but with the variables and the exponents, you subtract. So what's going to be the new exponent on the x here? So it's x to the 5th divided by x, we get Good. X to the fourth. Because if it's not written, it's 1. 5 minus 1 is 4. Question? All right, so you can write it like this, or you could put the x in the numerator if you want, because it didn't have a negative exponent, so you know it could be in the numerator. Either way of writing it is fine. 1 on the bottom. Do I divide before I raise to the power? No. No, you raise to the power first. So you would do that first. Refer to the power rule if you need to. What's going to be the numerator on this? Or not numerator, the exponent. Good. It's 2 times 2 is 4. And then we're dividing it by y to the 4th, which gives me what? Copy the y. So 4 minus 4 is anything to the 0 power is 1. So that kind of takes us to this rule that's down here. So it's kind of, since that showed up. So again, anything to the 0 power is 1. So that's our 0 exponent. And if you ever forget, just type it in the calculator. Anything to the 0 power is if you want. So then over here, 7x to the 0 power, anything to the 0 power is what? Did the 7 go away? So it's 7 times 1, which is just 7. And then we could work this out a little bit. Or I think that is one. So what do I do first? Do I raise to the power or divide first? Raise to the power, exponents before division, and 10 does, right? So what's going to be my exponent on this W? Good, 4 times 2 is 8. Over W to the 8, what's going to be my answer? My final answer will be 1. If you did the quotient rule and subtracted them, you would get this, which really just becomes 1, anything to the 0 power. I always think of it like when you have the same thing on top and bottom of a fraction, it always cancels out to 1 anyway. But either way, you should come to that same. All right, now last one, the negative exponent rule. So we're not supposed to have negative exponents in our final answer. If we do, you're supposed to, if it's not a fraction, pretend like it is. And anything with a negative exponent will move across the fraction bar and be rewritten as positive. And if there's nothing left, once you move it, put 1 as a place, not 0. But yeah. So anything that has a negative exponent, pretend it's over a fraction bar and move it across that fraction bar, rewrite it as positive. So then number 1, the -5, there's nothing going on with that. That is going to stay a -5. That one has a positive exponent. It's -5 to the 1, so we don't move that. But this -2 needs to go. So it's not a fraction already, so let's just pretend like it is. What's the only thing that has to move? The x to the -2. Move it across the fraction bar. So that means my final answer will look like this, and then rewrite it as positive. And I'll erase just so you can see what's happening, but yeah, so only things with negative exponents move. All right, number 2, I ran out of room, so I'll put it over here. Don't mess with negative exponents until the very end. So you might see them at the start of your problem. Don't apply this rule until you've already simplified everything else. So like, can we simplify 4 over 8? What is it simplified to? Good. And then according to our exponent rules, we do what with these exponents? So I get k to -3, which we don't like to be there. So as of right now, when we did the problem, it's in the numerator. But once we apply the negative exponent rule, this chunk with the negative exponent will move across. 1 will stay there and it'll be over 2k to the what? Third. Let me make that look more clear, but that's what it's gonna be. 2k to the third power. Sorry, it's so hard to write a clear proof, but yeah. So questions on our graphic organizer? All right, I think the examples are helpful. So I'll leave this up. Well, actually, I'll come back to this in case you missed something. But to make sure that this is completely filled out, this will be for like the next binder test. Now I'm gonna pass out the maze. The maze I do want turned in by the end of the class, so you'll have like 30 minutes to work on it. And the way that it works, so I'm gonna show you what it looks like, is it has a start, right? So you start where it says start, and you work out that problem. So for example, the one that's on my start is this. What's -8 divided by 4? -2. You do what with the exponents? What's 18 minus 6? All right, now to know where you go next, you see which answer it matches. Did I mess something up? I just don't see it. Oh, there it is. So then that tells me I go this way. And now this is the problem I do next. And then I work that out. And it's either this one or that one. So if you don't see your answer, probably you did something wrong. And then the other answers are like common mistakes that students make. So it's kind of like trying to trick you in a way. All right, but I'll pass this out. I'll go kind of back and forth. There's some people that need to get the first chunk of notes. So I'll pass that out, let you work on it, and then you'll turn it in before you leave. Any questions? Zen?